Okay, so today we're going to look at the same exact problem, predicting the prices of Toyota Corolla based on characteristics of the car, right? And last class, I believe we downloaded the file, right? And you moved it to your C data folder. So go ahead and start a new script, clean, brand new script. So today we're going to start looking at simple linear regression, okay? In the last class we discussed regression tree, right? So it's basically same model, or very similar, not exactly same of course, similar model to classification trees. The idea is we need to start branching our data set into smaller and smaller subsets so that in each subset we have observations which are close to each other, right? Very similar to each other. And that's how we can actually keep branching things and predict the price of the Toyota Corolla. So this is the file that we did in the previous class, right? So I'm just going to run it, all of it. And in the plots, no, this is what I want. I want to plot the regression tree, right? This is how we discussed the price of each individual car can be predicted, right? First it branches on the age of the car, greater than 33 or less than 33 months. And then depending on which branch you go, it keeps branching further and further, right, until you arrive to the final leaf, terminal leaf, and that gives you the prediction for that type of car. This is what we predict to be the price, right? So this is one type of the model when we're predicting the numerical target variable. Another type of the model that we're about to begin today, that's why I told you to start a new script, okay, is linear regression. You actually did learn linear regression in BUS Center 31, right? So this, in this class, in the next couple of weeks, we're going to go over the same model again, and actually we're going to add more features to the model, okay? So you will see how we can use, for example, categorical predictors in the linear regression. I'm pretty sure in BUS Center 31, Intro into Statistics, you used only numerical predictors. So we're going to take a look at how you can use categorical predictors in linear regression. And then later, after that, we're actually going to study the model, which is going to be the most difficult, turns out, model of the semester, which is called logistic regression, okay? So let me actually make it bigger a little bit. I believe 200 magnification is what we're looking for. Okay, so let's read the same data, okay? We're using same data set, Corolla, 1,000 cars, right? So I'm going to say Corolla underscore data. I can call it whatever I want, right? Corolla data, read.csv, and I know where the file is located, right? The file is on disk C, folder data, and it's called Corolla.csv. Corolla. Okay, Corolla. Yes. Corolla data. Okay, so if you look at the structure of what's inside the data, right, let's quickly look at the structure of the data, and here it is, okay? And you can see the same commands that I was running, right? So right here, first I'm reading the data right here, and then I'm showing the structure. So our target that we want to predict is the price, right? How much money the seller would like for the car. And predictors, what we're using, are age of the car in months, mileage, fuel type. Fuel type is categorical again, right? 3 different values. It can be either running on the gasoline, or diesel fuel, or liquefied natural gas, okay? And then horsepower, color, again, categorical predictor. It's kind of yes, no, 0, 1, with metallic color or anything else, right? Automatic transmission, 0, 1, 1 if it's yes, 0 if it's manual. And then engine volume, number of doors, and the weight of the car in apparently pounds, okay? All right. First, let's discuss coefficient of correlation, ladies and gentlemen, okay? So I actually have a pretty cool demonstration in another program called JUMP. Okay, but let's first discuss what is the coefficient of correlation. If you have two numerical variables, okay, x and y, in statistics you can calculate one number which is called coefficient of correlation, and that number tells you to what extent, how strongly these two variables are codependent with one another. Okay, well, let me actually show you an example. All right, so I'm going to start JUMP. You don't need to do the same thing. Where's JUMP? JUMP is right here. I'm just going to show you a pretty cool demonstration. So I believe it's in the help, sample data. Oh God, where is it? Teaching scripts, teaching demonstrations, and demo correlation. Yeah, this is the one. Okay, so here what I have is some variable x horizontally and some variable y vertically, whatever they are. Okay, x can be mileage and y can be the price of the car. Okay, or x can be advertising expenses and y can be sales. All right, so whatever they are. So true or false, you can kind of see that as x goes up, y also goes up. True, right? It's not perfect, right? But you can kind of see that it's like a cloud of points, right? Which looks a little bit like a straight line, right? Not exactly straight line, but you can see that x goes up, y goes up. And here you have coefficient of correlation calculated for you. Okay, so right now it says that with these points, x, y, coefficient of correlation 0.67. Okay, so let's see what will happen if I start rearranging these points to make sure that they don't look like a cloud of points, but more like a straight line. Okay, so I'm going to move these things around a little bit. So I'm going to stretch the cloud a bit, moving the points, and I will bring points from the sides to the center, so that they start looking like I have actually a straight line. And you can see that as I do this, my coefficient of correlation is being dynamically recalculated, right? What do you see? Tell me. What's happening to my coefficient of correlation? Getting close to 1, right? The closer the line becomes, the closer the points become aligned, like they form a straight line, right? The closer my coefficient of correlation is to 1.0. Okay, so this is pretty. Well, it's not perfect straight line, and you can see that my coefficient of correlation is 0.99. Right? If I keep moving these points even further, whoops, I missed that one. Okay, then you will see that I can get really close to 1, and you can guess that it becomes perfect 1.0 if my points, they form perfect straight line. Okay, so any straight line which is positively sloped, like this one, x goes up, y goes up, will have a correlation coefficient of 1.0. This is ideal case. Okay, that means that if I know the value of x, I can precisely calculate the value of y. Right? It's not a cloud of points; it's a straight line. I give you an x, you will be able to give me y exactly. Okay. Alright, so let me restart this thing, and I'm going to show you a different case. Instead of positively sloped line, now I'm going to make it negatively sloped. And this time around, let me go ahead and try to not make it 45-degree angle, but something else, okay? Something more steep, okay? So, let's see. I'm going to take this point and put it right here, this point and put it here. And again, the idea is that I'm going to make the points look like they belong on the same straight line. But now it's going to be not 45-degree angle, but something else. Okay? Oh, you see what I'm doing wrong? I'm doing the same thing, right? Positive slope. I told you that I'm going to do negative slope. Oh my God, I just lost 2 minutes of class time. That's unforgivable. Okay. So, let me go ahead and do it like this, okay? I'm going to move points more drastically, right, in different corners, like this. Alright. Okay. So as I move the point, what happens to, well, first of all, true or false, coefficient of correlation is negative. Negative means that x and y are negatively correlated. That means x goes up, y goes down, okay? And as I move the point closer to the straight line, tell me what you see with the coefficient of correlation. It's getting closer to what value? If you would have to guess. -1, right? I started with -0.4 and now I'm -8 and -0.8, and soon enough I'm going to be -0.9. There you go. Okay, and you can see that the slope is not 1, right? It's not a 45-degree angle, right? It's more steep line, right? But the coefficient of correlation is still getting closer and closer to -1. Now I'm going to move this one last point, and there you go, okay? And, yeah, so I have some noise going on here. That point probably needs to be moved. Yeah, it's pretty good, right? Not perfect straight line. Done. Yeah, good question. What happens if you have outlier, right? So in other words, this is your perfect straight line, but what if you have an outlier right here? And immediately it screws up the correlation, right? That's basically a bad effect on the outlier. So we're going to actually discuss later, next week probably, what outliers do to your regression. Yes, they can mess things up, okay? Outliers are bad things that can kind of make your otherwise good pattern look not so good, okay? So, ladies and gentlemen, let me close this and let's see. So, coefficient of correlation. Coefficient of correlation. Let's use English letter R, because typically for coefficient of correlation, statisticians use Greek letter rho, but let's use R. R, coefficient of correlation. Coefficient of correlation. Again, it tells you to what extent two variables, numerical variables, x and y, are related to each other, right? If they form a fairly nice straight line, then your coefficient of correlation will be either +1 for the positive slope or -1 for the negative slope, right? Everything else basically is just different kind of shades of gray, right? So if coefficient of correlation is not close to plus or -1, that means that your correlation is not perfect, right? And the further away you are from 1 or -1, the worse it is. Can you guess what would be absolutely worst coefficient of correlation to have? 0. 0 means really your x and y are not related. Hold on, do I still have, let me see if I can still bring this up. Yeah, I still have it, right? Well, let me show you the case of 0, all right? Should have done it earlier. Okay. Let me show you the extreme case, right? Teaching script, teaching demonstrations, correlation. Okay, so same thing, right? Where is that? Yeah. So right now I kind of sort of see that there is a straight line, but not exactly right, but at least it's a cloud of points that looks like it has the trend. Let me click around this cloud of points and add more points to make this linear relationship worse, okay? What do we see? Well, we kind of see that x goes up, y goes up, but it's not as obvious anymore, right? Points are more dispersed, okay? And that is reflected in the coefficient of correlation. Now it's 0.36. Now I'm going to click a little bit more around and add some more points, so it's not a straight line anymore, right? It looks less and less like a straight line, okay? And that is reflected in the coefficient of correlation, 0.21. Now let me fill these gaps, these pockets, right? And now you can't even see the straight line, original, anymore, right? It's pretty much a random cloud of points with no sense of direction inside of it. And you can see the coefficient of correlation is very close to 0, okay? So you're right, 0 correlation is absolutely worst case. It cannot get much worse than that. So, ladies and gents, let me close this and go back to our write-up. So let's adopt the following informal way of classifying strength of the correlation. Okay, 3 cases. If the coefficient of correlation absolute value is between 0.7 and 1, that means either on positive or negative side, right? If it's between 0.7 and 1 or minus 0.7 and minus 1, that's why I have absolute value, right? Then we're going to call this case strong correlation. Strong correlation, okay? That means that if I have an imaginary, whoa, what happened? Okay, correlation. If I have an imaginary line, an imaginary plot, like x versus y, right? Then the plot looks a lot like straight line. Maybe not exactly, but fairly close, right? Strong correlation. Okay, if my coefficient of correlation gets smaller, closer to 0, it's between 0.3 and 0.7, again, either on negative or on positive side, okay? It's between plus 0.3 and plus 0.7, or minus 0.3 and minus 0.7, then I'm going to call it moderate correlation. Moderate correlation, okay? Nothing special. It's okay. Not very good, but not very bad at the same time. And if my coefficient of correlation is close to 0, if it's between 0.3, right? Here. 0.3. So it's between minus 0.3 and plus 0.3. Then, can you guess what I'm going to call this? Weak correlation, right? So strong correlation if it's close to plus or minus 1. If it's close to 0, from minus 0.3 to plus 0.3, I'm going to call it weak correlation. And if it's kind of in between, then it's moderate, right? Again, this is an informal way to classify correlation. Right? This is not exact science. This is kind of a gentleman's agreement how statisticians decided to classify the strength of correlation. And these boundaries, 0.3, 0.7, they're not set in stone. If you look at different textbooks, you will see 0.2 and 0.8. So it's all over the place. So in this class, let's use 0.3 and 0.7. Okay? All right. Now, let me go back to R. Here's our R. Okay, so let's do the same exact thing as we did in the previous class, right? Remember, we had a discussion, kind of, right? I asked you, if you would have to pick out of all characteristics of the car, which one affects the price the most? What did you tell me? Mileage, right? How extensively the car is used. So today, let's assume this simple-minded, simplistic approach that nothing is important except mileage in determining how much money the car will be priced at, for example, used car dealership. Okay? So, therefore, my X, my predictor, is going to be mileage, and my Y, target, is going to be price. True or false? Both of them are numerical variables. True. I measure price in dollars, and I measure mileage in, well, miles, right? Okay, so, and I believe in the previous class we did the scatter plot, right? Of miles versus the price. Okay, so let's do it again, okay? Reminder, scatter plot is built in. I mean, this is elementary, very basic scatter plot that you don't need to bring any external libraries. There are more sophisticated scatter plots. We're not going to cover them in this class. Like, for example, there's a library called ggplot, and more advanced version ggplot2. That's right now actually is fairly popular graphing library that has much more superior graphing capability. Okay, I don't want to go into the details of ggplot, so let's use the built-in plot. Okay, so for the plot, I can just go ahead and basically specify two things, right? What is my x horizontal and what is my y vertical? Horizontal predictor is what? What am I using as a predictor? Mileage, and the target is price, right? So I'm going to say Corolla data $ mileage, that's my x, right? Whoops. That is my x, and after that Corolla data $ price, that is my y. And if you run this line, okay, that's supposed to be scatter plot. Let me put a comment down. Scatter plot. Okay. And this is what it is going to look like. All right. So mileage is horizontally. Let me make it a little bit stretched. Mileage is horizontally. That's my x, and price is vertically. That's my y. Okay. Well, do you like the labels for x and y? Like, imagine that I'm preparing the plot, the picture for my presentation. Do you want it to look like this? Probably not, right? Remember how we did modify the labels for the horizontal, vertical axis in a different plot? I believe it was, oh God, what was it? Bar plot, if I remember correctly. What did we do? How do I change the label for the x and y? X lab and y lab, right? So I can say x lab, x label is mileage, y lab equals price, and okay, mileage, y lab is price, and if I want a title for the entire thing, that is called main, right? Not a title, but main. Main equals let's see, price versus mileage scatter plot. Something like that. Time to capitalize that. Okay, so if I rerun this thing, this line, then it gives me updated, more pretty version of my scatter plot, right? Mileage, price, and the nice title. Okay? Alright, ladies and gentlemen. Well, does it look like there is a relationship between x and y? Mileage and price? Yes. Because if I look at the lower prices, mileages, the price tends to be on the high end, right? And as the mileage goes up, I can see that the price keeps dropping, right? Okay, so it looks like I have a case for actually creating a straight line dependency. Now, let me tell you right off the bat, probably it's not going to be perfect, right? Why? Because that doesn't look exactly like a straight line to me, right? If anything, I can see the curvature. Would you agree? It's not straight line. It's the prices at the low mileage, they tend to be on the high end, and then as the mileage goes up, they initially drop very quickly, right? And then it kind of flattens out and becomes more like a straight line, right? But I see some weird stuff going on for the low mileages, right? Okay. But let me go ahead and, the reason why we had this discussion about the correlation, let's go ahead and find out how correlated, like the measure of correlation between mileages and prices. Okay, so coefficient of correlation, COR, core, okay, and all I have to do really is to tell the coefficient of correlation function what's my x and what's my y. So I have to say Corolla data $ mileage versus Corolla data $ price. And when I run this line, it tells me that, hey, dear sir, here's a coefficient of correlation. Okay, so this is the line that I executed, in case you were not typing as fast as I did. All right. So minus 0.596. Is minus sign surprising or not? Not really, right? Because if I fit the straight line, right, into this cloud of points, then I'm going to pretty much see that it has to be negatively sloped, right? Hence, the coefficient of correlation should be negative, right? So minus sign is not amazing. Now, according to our informal classification that we just discussed, am I dealing with weakly, mediumly, funky word, medium or strong correlated variables? Moderate correlation, right? So there is a moderate correlation. And my guess, the reason why it's moderate is because it's not exactly straight line. So this portion of my graph points that are at the low values of mileage and high prices. That's what's messing it up. But actually, if you look, like earlier, Don asked the question, what about the outliers, right? Do you see 3 lonely points on the top, right here? Really expensive cars, right? $30,000 or euros, whatever the units are, right? At low mileages, right? They are unusual, right? Likely, these 3 points are outliers, right? Cars that are, I understand they're almost brand new, so they have to be expensive, but this is crazy expensive, right? So these are likely outliers. And that's partly what's messing up our picture with the coefficient of correlation, okay? But basically, what we're going to start in the last 10 minutes of this class, right, and then on Monday we're going to continue, we're going to try and model the dependency of the car price on the mileage as the linear function. This is going to be not perfect, this is just an approximation. So in other words, I'm looking to find an equation like this, okay? And you told me in the previous class that straight line equation in the United States, at least, is y equals mx plus b. Is that correct? M is the slope, you told me, b is the vertical intercept, and x is your predictor, independent variable, right? Okay, so in my case, here's what I'm looking to find, right? My y is the price, okay? My m is, well, whatever slope, right? I need to find slope. The x is the mileage, so I'm going to say times mileage plus b, right? Plus the intercept. So in other words, if I find out what my m, the slope, is, and what my b, the intercept, is, that should give me a pretty good idea how to predict the price for any car for which I know the mileage, right? Okay, so this is called simple linear regression, ladies and gentlemen. Okay, simple linear regression. Okay, why do we call it simple? Because we're assuming very simplistic model of the world. We're saying mileage is the only thing that affects the car prices, while in actuality we know it's not the case, right? Say meow, right? Here you go. In actuality, what else can affect the car price? It can be age of the car, right? Say what? Exactly, it's been in an accident or not, right? How do we find that out, by the way? Carfax, Lemon check, right? How many owners the car had? Probably another one, right? If it changed like 10 owners, people were buying it and then, oh my god, no, I'm going to sell it. Something's wrong with it, okay? Extra features, right? Such as, I don't know, sunroof, leather seats, CD changer, built-in GPS, extra loud exhaust, right? Anything like that, right? Customized. Heck, even color can affect the price, right? Cool-looking black car as opposed to, you know, orange, funky-looking car can make a difference, right? So, but here we're saying, nope, the only thing that matters for us is mileage. Okay, so let me show you how can we build a linear, simple linear regression model. It's actually done by the built-in function, so we don't need to bring external libraries. Okay, so I'm going to say Corolla underscore simple underscore linear underscore regression. Okay, model. Let our variable be very long and detailed. Corolla simple linear regression model. Okay. All right. I'm using the built-in function LM. Can you guess what LM stands for? Linear model, right there. Okay. LM, not N. LN is logarithm, right? So LM, and I actually have to specify 2 parameters. One of them is exactly what we did for the classification or regression tree. What is your target and what is your predictor? My target is price, right? And I have to say tilde, and my predictor is mileage, right? Simple as that. Mileage, bam. And after that, which data to use, right? In order to build a model. So I'm going to say data equals, what's the name of my data? Corolla data. This one, right here, right? Bam. I run this line, and if you don't see any red, that means you did everything correctly. Okay? Corolla simple linear regression model. Linear model, price is the target, mileage is the predictor, and use the data Corolla data. Okay? Simple. All right. Well, now, ladies and gentlemen, let's take a look at the output. Okay. So, after all, what I'm looking for is m, the slope, and b, the intercept, right? What are they? So, summary of my model. Corolla. Thank God for this thing, right? For this feature. It's called IntelliSense, right? At least in Microsoft tools. Intelligent tooltip for you, right? So, Corolla price regression. No, simple. This one, right? Corolla simple linear regression model. Bam. Run this line.
When it does the simple fill-in thing that you were showing us, does it mean anything? Like the one you showed like 3 different dots, where there was like a box option, like what is the
Corolla.
delineation?
Oh, these things? Different. What do these different things mean?
The little like pictures on the side.
Oh, little pictures on the side. Yeah. So little pictures. Yeah, icons actually can tell you what exactly you're looking at, right? So this one, which looks like a table, right? That's data. Okay. So Corolla data. So there is a picture of table, right? And this one actually, well, this is the name of our object, right? So it's not a data really, it's kind of an object thing. And as a person who did my fair share of programming in my life, I can tell you that this is the symbol from Microsoft suite of development tools, okay? So that to me it means that our studio at least was built either in Visual Basic.net or probably C#.net. That would be my guess, okay? But this kind of tells you that this is an object, okay? This is a table and this is an object. So yeah, the icons are meaningful, yeah. But I need to pick this one, right? All right. So let me go ahead and run that, and here is my output, okay? Oh God, here's my output. Bam. Well, what are the most important things that I'm looking for in the output? Well, again, we're building simple regression. That means I need to know what the slope is and I need to know what intercept is, right? Well, they go in the column estimate. So intercept, that is my b, right, in the equation, is this one right here, and the slope for the mileage m is this one right here. Okay. Whoops. Hold on, we're about to cut off the power. That's what they say. Microsoft are beautiful people, okay? So they updated, you know how they update your system without you actually asking, right? They're like, okay, it's about to update. You can't do anything with FYI. Okay, so on one of these updates, before that, it would tell me, hey, you know, 10% battery remaining, you need to plug in, right? After update, it just stopped doing that. It just said, that's it, I'm cutting off right now. Can't do anything with it. So it's like wonderful. Okay. So here's my main output. So from the output, therefore, here's my model, right? I'm going to write it down. Model is this. To predict the price of the car, all I have to do is take m, which is what? Which is my slope, right? Slope is right here. I'm just going to copy paste it. Here's my slope. Okay, times the mileage, plus the intercept, and the intercept is right here. So again, you're looking in the column that's called estimates, right? Yeah. This is my model, literally, okay? So now I can use it pretty much, right? I can go ahead and take any car, let's say with 25,000 miles on it, okay? Plug into this equation, and the calculation will tell me an estimate. It's not going to be exact number, right? Because this relationship is not perfect, right? It's going to be an estimate how much money this car I expect to be priced at the used dealership, for example, okay? Make sense? Any questions? Should be fairly straightforward. You know what? And let's try to do this thing. I believe we only have time for one more thing, okay? Let me go ahead and try to plot the line on this graph, okay? Because this is a straight line, right? I only see visually how does the line cut from my cloud of points. So here's what I need to do. I need to say AB line and I just need to tell what line to plot. And the line corresponds to my linear regression model, right? So Corolla linear regression, simple linear regression model, this one. AB line, and just type the name of your model, just like that. Okay? So when you run this command, this is what you will see. Okay? AB line, and just tell what your model called. And there it is. Okay? So even from this picture, you can see that my model is not perfect, right? My model is not perfect because I have, like for the low prices, I have a bunch of points above my line, right? For the medium kind of prices in the middle, I have a bunch of points below my line, right? And for the high mileages, I have a bunch of points again above my line, right? Ideally, it shouldn't be the case, right? Ideally, my line should cut through the center of cloud, and roughly speaking, I should have half of the points above, half of the points below, and it should be evenly distributed, right? That would be ideal case. So when I see anything like that, that immediately tells me that probably my linear regression is not the best model here, but let's use it anyway. So on Monday, we're going to discuss how to interpret the coefficients of the model, like verbatim, right? How to make sense out of these numbers, and also how to analyze things like, for example, is that a significant model? How accurate is the model? Okay, so we're going to discuss model accuracy, just like what we did for classification trees. Okay, only this time around, it's not going to be accuracy, misclassification rate, because there is no classification here, right? There is no yes/no responses. The response is a number. So we have to use some other measures of accuracy and performance. Okay. All right. So we're done for today. By Monday, please have your code ready, and again, check the code on these machines in this room with the seed value of 129. Okay?